Alg2T Trig, Chapter 1, Section 3, talking about function notation and evaluation. If we're dealing with a function, anything where the inputs go to one and only one output, we use the notation f of x. That's how this is read. This is read f of x. It's not f times x, and that can get very confusing for students pretty often, but it's f of x. Whenever we see this sort of action, we know what we're dealing with as a function, and that's really nice because we can have confidence that every input will only have one output. It doesn't have to be f of x, it could be g of x or h of x or a of b or d of t. All those things, when you see them written like that, when you're dealing with functions, tell you you have a function. For example, the function p of c, it looks like p times c, but p of c could be a function that gives you profit based on the input of cost. Or d of t could give you a distance based on your input of time. These are all examples of functions, pretty basic and simple things. F of x means y, like literally. The whole symbol f of x is just representative of the dependent variable or the outputs. Some people think it's kind of silly. I can write y equals negative 3x plus 4 and f of x equals negative 3x plus 4. If this literally just means y, what's the point of even having this? Well, there's a few really nice points. One of them is, A, you know you have a function when you see that notation, but it also makes seeing inputs and outputs a lot simpler. Here, if I wanted to have an input of 4, I would write x equals 4 and I would switch to a smaller pen. I'd write x equals 4 and I would say y equals negative 3 times 4 plus 4, which is negative 12 plus 4, which is negative 8. So I'd say y equals negative 8, and then I would have 4 comma negative 8. But here, if I want to say that the input was 4, I would write that in place of this x, f of 4. Now I know the input was 4, but the whole entire y value itself, is still equal to negative 3 times 4 plus 4. So I do my work and I get negative 12 plus 4, which is negative 8. So I really have f of 4 equals negative 8. And here I see an input and an output side by side right next to each other without having to rewrite the ordered pair. In fact, I can build tables really easy. F of 1 would give me 1, f of 2 would give me negative 2, f of 3 would give me negative 5, and f of 4 we just did is negative 8. And here it's basically like I just built an xy table, where these are all my x's, all my inputs, and these are all my y's. So the key distinction to understand is that the f of x itself, the whole entire thing, this means y, whereas this little piece inside is the input x. And that's really useful, but kind of tricky to get a feel for. So I want to do a couple examples. It'll be a real short video. Here I have g of x. I just called it g of x instead of f of x because I want to start showing you different letters and combinations. And whatever I plug in, this right now is called my rule. This is called the function rule. It has an equation. And when I'm given that, now I have my y value defined. The y value is going to be all this action here. All this action here is going to spit out my y value based on what x is. Well, suppose that my x value became a 10. Wherever this x got replaced with a 10, so this x here gets replaced with a 10. 10 minus 3 is 7. 5 times 7 is 35. So I'm really doing 35 plus 2. So g of 10 is 37. I now know that if I plug in a 10 for x, I get out a 37 for y. And if I do g of negative 5, it'd be 5 times negative 5 plus 3 plus 2. Well, negative 5 plus 3 is negative 2. The absolute value of negative 2 is 2. 5 times 2 is 10 plus 2 is 12. So the input was negative 5. The output was 12. I'm going to do something here. Gosh, that looks hideous. I'm going to do something here that seems kind of stupid and silly, but I think it can be really helpful if I plug in something that isn't a number. What if I do g of Batman? Well, the idea is this input became Batman. So now I'm going to have this equal 5 times the absolute value of Batman minus 3 plus 2. Now I obviously can't solve that at all. There's nothing I can really do to work with that. But I'm just trying to show that whatever you put in this space here, you're going to put in this space here. So over here, I've got the function h of a. Let's write it as h of a. It's got a's here. And if I wanted, I could find h of 2a. So every place where I had an a, I'm now going to have a 2a. Notice that only the a's are getting replaced with 2a's, not the negatives, not the 2a's already. Each and every a is by itself becoming a 2a, and I'm plugging that into parentheses. Now if I were to do the squaring, I'd get negative 4a squared plus 4a minus 3. And if I wanted to find h of x plus y, and right now this probably feels like nonsense, because you're used to seeing all the number stuff that we did over here, but I'm trying to get the point across so I can plug in inputs and outputs of my choice. Well, then x plus y was here. In fact, I should change color for all this. X plus y took place of this a, so it's going to go in there and there. It's going to become negative x plus y squared plus 2 times x plus y minus 3. And I'll actually, so these I can simplify. I can do the squaring and calculate and stuff. I'm not going to bother doing that right now, but I could. But I could also, plug in some numbers. H of, and we'll just stick with 10. That gives me negative 10 squared plus 2 times 10 minus 3, which is negative 100 plus 20 minus 3, which is negative 83. The input was 10, and the output was negative 3. This is called evaluating functions. I probably should have written that up at the top. But you plug in numbers for x and see what you get out for y, which means you're plugging in numbers for x and seeing what you're getting out for f of x or h of a or g of x or whatever your things are. Thank you for your time.